In this video tutorial, I will be deriving the whole life assurance notation AX. This will be done in the simplest way possible for the understanding of all the viewers. Firstly, we need to understand what a whole life assurance is. By definition, a life insurance contract with level premiums that has both an insurance and an investment component. The insurance component pays a stated amount upon death of the insured. Obviously, there is much more to it when viewed from an actuarial point of view. For better understanding, a timeline must be drawn. This timeline is the key to deriving AX. We can clearly see that the timeline will start by the person acquiring the whole life assurance policy. Eventually, after a year passes, we will arrive to the X+1 stage. Since the benefit is paid in arrears, we do not consider the surviving possibility at point X+1. This is due to the fact that to get paid at point X+1, one must die between X and X+1. Q denotes the probability of the policyholder dying between X and X+1, which would mean that the benefit would be taken at that time. V, on the other hand, denotes actuarial discounting, which by definition is the present value of €1 to be paid 1 year from now. In the next year, we would have the scenario where the person survives between X and X+1. There is also the chance that the policyholder would die between X+1 and X+2. This is what Q denotes, that is, the death of the policyholder. V is squared here for the reason that this is the present value of the benefit to be paid from the year when the policy was purchased, which is 2 years from the inception of the policy. Moreover, we arrive to year 3, where we find P squared, Q, and V cubed. P is the probability of the person surviving between X and X+2. Whilst Q is the probability of the policyholder dying between X+2 and X+3. V is cubed here for the reason that this is the present value of the benefit to be paid from when the policy was purchased up until year 3. This goes on ad infinitum. As we can observe from the timeline, a geometric progression can be determined, with the first term A being QV, which can be seen in the timeline at X+1, and R is defined as the common ratio, which is equal to PV, because from 1 year to the next, there is the chance of the probability of surviving together with the actuarial discounting of the previous years. Now we shall start working the proof out. Since we have a GP, we will use A all over 1 minus R. Since the geometric progression, as said before, goes on to infinity and does not have a defined end term, by substitution, A is equal to QV and R is equal to PV. By definition, we also know that V is equal to E to the minus delta. P is equal to E to the minus mu, and Q is equal to 1 minus E to the minus mu. Therefore, by substitution, we will get this equation. since we have e to the minus mu times e to the minus delta. Since we have two same terms which are e, we can add the powers. That is all from me. I hope you found this video interesting and it helped you understand this key actuarial concept. If something is unclear, please don't hesitate to leave a comment. All queries will be answered given time.